Good evening to another online teaching today on Zoom. We try as much as possible to look at basic areas. But the presenter is Ing.Momoh Kenie. I'm Ing.Momoh Kenie. Just in case you have comments, you want to give a comment or you want to contribute to any of the programs, the video programs, you can do that via WhatsApp on 076-6273-336. Today we are looking at basic physics. What are some of the things that you are required to do, more especially for those who are pursuing the bachelor degree in the engineering or BSc in science related courses? And then we want to look at again candidates who are preparing for the WASSCE exams. Have in mind whatever you do at the WASSCE level, you have to do part of that at the first year in the BEng and the BSc courses. Now there are areas that normally appear in the exam. Whatever way you look at it, when you look at the physics question paper for WASSCE, you always see these topics, more especially question 1 and question 2. Anytime you take the question paper, you have some areas in question 1 and question 2 that you must be able to handle. And the areas that you are supposed to handle in the physics for that aspect will be motion under gravity. So that one becomes motion under gravity. Motion under gravity. If we are looking at motion under gravity, there are basic things that you should know. What are some of the things that you know? Already you might have known the symbolic equation, the most frequently used equations in motion, the rectilinear motion. There are basic equations, and the equations that you should know before I progress are, you should know that V is equal to U plus AT. You must be able to know that S equals UT plus half AT square. You must be able to note that V square equals U square plus 2AS. These are the most familiar equations, the most familiar rectilinear motion equations. Now, when we want to look at motion under gravity, what comes to mind now is we are going to change. Anytime you want to discuss motion under gravity, you always change the A to G. That means all the A's that you are seeing here, they change to G. All the S's that you are seeing, they change to H. Those are the basic things that you should know. Whether the object is under case 1, I will be looking at the cases in simple terms. What you should know that A changes to G, the acceleration becomes the gravity, the S becomes the height. Now that means there is no acceleration when you are above the ground, and there is no gravity when you are on the ground surface. So anytime you are on the ground, you make use of the acceleration. When you go beyond the ground surface, you look at gravity. Now, under motion under gravity, there are 4 cases that you should know. Once you are able to look at all the 4 cases, you can solve questions related to them wherever you see them, wherever you are. The 4 cases that we try to look at will be case number 1, particle projected vertically upwards. Particle projected vertically upwards. Particle projected vertically upwards. Vertically upwards. The other thing you should know is particle projected vertically downwards. Particle projected vertically downwards. Particle projected vertically downwards, which sometimes we call horizontal motion. Call that horizontal motion. The other case you should try as much as possible to know is particle projected upward from a height above the ground. Particle projected upwards. Particle projected upwards from a height above the ground. And then the 4th case is particle projected at an angle. We call that projectile. When they are projected at an angle, we now call that projectile. If you are able to look at all these 4 cases, you can solve questions wherever you are. Now we want to look at the first one. We'll be looking at them one after the other. If you want to look at these things one after the other, we look at the first case. And the first case is particle projected vertically upwards. So first case is particle projected vertically upwards. Particle projected upwards. So preferably when we write particle projected upwards, we mean from the ground. That is the case you are on the ground surface. You are now on the ground surface. You project an object this way. So case number 1 is saying you project an object this way. That is particle projected vertically upwards. Case number 2 that says you project a particular body vertically downward. That means you are above the ground, you drop an object. Case number 3 says you now project an object above the ground. Sometimes when you want to project object, you will not be on the ground surface. You climb to a particular level and then you project the object. Sometimes again, the fourth case is when they are now projected at an angle. What do we mean by an angle here? Projected case. You will not be interested in sending the object this way, but you are on the ground, you send the object this way, you now send it this way. So those are the 4 cases. The first case now is vertically motion or object projected vertically upwards. Now let us look at the conditions. What are some of the things that you should know? That anytime an object is projected vertically upwards, anytime the object is projected vertically upward, case number 1, that the acceleration, we said they change to gravity, but when they are doing that, they become minus g. Anytime the object is projected vertically upward, the a becomes minus g. Anytime the object is projected vertically upward, v is equal to 0 at maximum height. At maximum height. Maximum height. So anytime I send an object vertically upward this way, the highest point where the object reaches, then it falls. At that point, there is no velocity. We say the final velocity, which is v, is equal to 0. So there is no final velocity at the highest point of projection. Wherever the object reaches, then it falls. There is no final velocity at that particular point. Now, if that is the case, let us say we have the ground surface here. This is the ground surface. You project an object from the ground this way. The object will use this path until when the object reaches the highest point. When it reaches the highest point, it will make a curve before it falls down. That means anytime you project an object this way, before the object falls, it must have to turn at the top. Then it falls to the ground. So if that is the case, at the highest point where the object reaches before it falls, at that point, we say the final velocity is equal to 0 at that point. There is no final velocity at that particular point. And if that is the case, from this point, coming to the ground surface become the maximum height. That is the maximum height of projection. The maximum height, by definition, is the highest point reached by the object that is projected. The highest point reached by the particle is the maximum height. Now let us look at basic equation. Few minutes ago, I said there is an equation that says v equals u plus at. But when we are now changing, we have v equals u. Instead of a, we put a is now becoming minus g. When anytime the object is going upward, a becomes minus g. So if that is the case, we have v equals u minus gt. We progress. I have the right to put v equal to 0 because at the highest point, when the object reaches the highest point, v is equal to 0 at that point. So if I do, I have 0 equals u minus gt. If I want to take minus gt to the left, the moment I take minus gt to the left, become positive gt, and that becomes u. What I'm interested in is small t. How can I get small t? I can get small t by dividing both sides by g. If I do, gt over g equals u divided by g. That is what I would have. And small t becomes u over g. What do we mean by small t? Small t is the time taken by the object to reach the highest point. The time taken by the object to reach the highest point. Anytime you want to calculate the time taken by the object to reach the highest point, you use small t. And this is time to reach highest point. Time to reach highest point. Highest point. That is one of the things you should know. Small t equals u divided by g when you want to get the time taken by the object to reach the highest point. Now we move further to another case. Another thing you should know, still under this motion. If we still want to progress under this motion, let us now look at time of flight. We now want to look at time of flight. Time of flight. The symbol we use for time of flight is capital T. What do we call time of flight? Time of flight is the time taken by the object to be in air. So if I can break that down, is the time required by the object to move from where it was projected, that means from the ground surface, to go to the highest point and back to the ground. So if you are now interested in capital T is different from small t. Small t is just the time taken to go to the highest point. When the object reaches the highest point, that object has to come down again. So if that is the case, the time it takes the object to go to the highest point and back to the ground is known as time of flight, and we represent that by capital T. So capital T and small t are not the same. So ideally, what I am saying, the time taken by the object to move from the ground here to the highest point is small t. The same small t is required by the object to move from here to here. So what I am saying, if it takes 5 seconds from here to here, then it will take 5 seconds again to move from the top to the ground. So if that is the case, the time of flight, capital T, becomes the time it takes from here to here, we said is small t. If that is the case, the time from here again coming to the ground becomes small t. So it becomes small t plus small t. So if that is the case, capital T equals small t plus small t becomes 2 small t. But we know very well, we know the value for small t. We know that small t is u divided by g. Few minutes ago, that was what I did. So if that is the case, capital T becomes 2. Small t is here, we put u over g. It becomes u divided by g. So anytime somebody says the time of flight or the time required by the object to be in air, you say 2u divided by g, where u is the initial velocity and g is the gravity, which is 10 meters per second square. We still progress now. Where are we going? We now want to get the formula for the highest point reached. How can you calculate the formula for the highest point reached by this particular object that is thrown? If you want to look at the maximum height reached, you can recall the equation. A few minutes ago, I said v square equals u square plus 2as. So what we are now changing here is v square equals u squared. Wherever we see a, we put minus g. So I'll put minus g here. Wherever I see s, I put h. I said s changes to h. So if that is the case, I have v square equals u squared plus times minus is minus. 2 times g times h is 2gh. We know very well that at the highest point, the moment the object reaches the highest point, v is equal to 0. So if I put v equal to 0 in that equation, I will get 0 square. V is equal to 0 here now at the highest point. That is giving us u square minus 2gh. Now 0 square is same as 0 here equals u square minus 2gh. So if I take minus 2gh to the left, it is becoming positive 2gh, and that equals u square alone on the right. Now if I want to get height, I'm interested in h. The only way I can get h here is to divide both sides by 2g. So I will have 2gh equals u square. I divide here by 2g. I also divide here by 2g. So the h that I have got is what we call maximum height, and that is given by u square divided by 2g. So anytime somebody tells you to find the highest point reached, when you send an object vertically upward from the ground, somebody will now want you to get the highest point reached by that particular object. The formula becomes u square plus 2gh. Stop that.